So let's say we were given this triangle, and we're going to use this the half angle formulas to be able to find the following values of this given triangle here. Okay, so now let's just remember that the sine of x over 2 is going to be plus or minus the square root of 1 minus cos of x divided by 2. Since it's a triangle, let's just worry about the positive value for this. The cosine is going to be the adjacent over the hypotenuse. And so this is going to be equal to the square root of 1 minus 3/5 divided by 2. To be able to simplify this, we're going to use that trick, just like we've done a number of times. We're going to multiply the numerator and denominator by the same number. Okay, so let's multiply by 5 over 5. And what that'll do is that'll distribute that 5 to both of these terms. And so we will have the square root of 5 minus 3 divided by 10, which is going to be the square root of 2/10, which is the square root of 1/5, which can be written as the square root of 1 over the square root of 5, which is 1 over root 5. And then we can finally multiply by root 5 over root 5 to rationalize this. And so the cleanest answer that's rationalized that we can get out of this is going to be the square root of 5 divided by 5. Okay. We're going to do the exact same thing with the cosine, except we're going to change this to a plus now. Okay, so that's going to be positive root of 1 plus 3/5. Okay, so remember, the only difference is we're just changing the sign there, divided by 2. All right, and that's still, this is for part B, by the way. And again, we're just using the cosine formula, which is a positive. We can multiply by 5 over 5 and distribute. Okay, so that's going to be the square root of 5 plus 3 divided by 10, which is going to be the square root of 8/10, or the square root of 4/5, or the square root of 4 over the square root of 5, or 2 over root 5. And then if we multiply by root 5 over root 5, that's going to give us 2 roots of 5 over 5. All right, now, the good news is for the tangent, we could just divide the sine by the cosine, right? So for part C, the tan of x over 2, we could just take root 5 over 5 and divide that by 2 roots of 5 over 5, right? Or multiply by the reciprocal. So we would have root 5 over 5 times 5 over 2 roots of 5. And we would just be left with 1/2, right? So that's probably an easy way to be able to get to the tangent function. The last thing we'd have to do is we'd have to find 2 sine of x over 2 cos x over 2. And so we already know the answers to these. Okay, so right here is sine of x over 2. Here's cos of x over 2. And so we just multiply those out. So for part D, 2 sine of x over 2 cos x over 2. That's going to be 2 times root 5 over 5 times 2 roots of 5 over 5. Okay. And then if we multiply this through, root 5 times root 5 is going to give us a 5. And then 2 times 2 is going to give us 4. So we have 4 times 5. 5 times 5 is going to be 25. And then we certainly know that the 5 and the 25 can simplify. So ultimately, we would just end up with 4/5. Okay. All right. So another example, and this is an example we've seen for both the half angle as well as, I'm sorry, for our double angle, as well as some of our other sorts of problems. We have a given angle, so we have cos of theta equals 1/3, theta is in quadrant 4. So we want to find the exact value of the following. All right, now, before we do anything, all right, we need to figure out where does cos of theta over 2 fall. Okay, so that way we can figure out what the sign is. Because remember, these have plus minuses on them, okay, or at least these two do, okay? So the tangent will take care of itself because that's just going to be sine over cosine. All right, now, if theta's in quadrant 4, that means that theta is between 270 degrees and 360 degrees. but we're looking for theta over 2. Okay, and again, that's just because we want to determine if it's plus or minus. Okay, and so what that means is, well, 270 divided by 2, if we go into our calculator, that should be pretty easy to figure it out. So 270 divided by 2, that's going to be 135. Okay, so theta, oh, I keep doing equal to unnecessarily. So that's going to be 135 degrees. And then 360 divided by 2 is 180 degrees. All right. So theta over, and this is theta over 2, by the way, theta over 2 falls in quadrant 2. Okay. So theta over 2 is in quadrant 2. All right. And so if we have our all students take calculus, the sign is going to be greater than 0. Okay. So this one's going to be greater than 0, and this one will be less than 0. Okay, so that's the first thing that we need to do before we attempt these problems, is determining where does theta over 2 fall. Okay, now that we know that, let's build a triangle. All right, so here's our triangle with theta. All right, and we know that the cos is equal to 1/3. That means that it's the adjacent, or adjacent over hypotenuse. So the hypotenuse is 3, the adjacent is 1. And if we were to find this side, which we call b, we would have 3 square equals 1 square plus b square. This is 9, this is 1. So we subtract 1 from each side, we get 8 equals b square. Square root of 8 equals b. But we know that square root of 8 can be written as root 4 times 2, or 2 roots of 2 is equal to b. Okay, so right here, that's 2 roots of 2. All right, that might be helpful when we go to try to figure out like the tangent or something of that nature. But for right now, okay, we're just going to go ahead and find the sine and the cosine. All right, so the sine of theta over 2, finally, now remember, it's either plus or minus the square root of 1 minus 1/3 divided by 2. Okay, so remember, it's 1 minus the cosine. Right? We can do that trick, and we certainly know that because it's in quadrant 2, that sine's going to be positive. So let's not use this negative anymore. Okay, we're going to use our trick where we multiply and divide by 3. So multiply 3 over 3. And so another way to write this expression is to distribute that 3. And so this would be equal to the square root of 3 minus 1 divided by 6. Okay, or the square root of 2/6, or the square root of 1/3, or the square root of 1 over the square root of 3, or 1 over root 3, or if we were finally to rationalize that, that would be the square root of 3 divided by 3, positive. Okay. Now, for the cosine of theta over 2, okay, which is part B, this one's going to be negative. Okay, and it's negative because, again, theta over 2 ends up in quadrant 2. Okay, so, and we know that only the sine function, as well as the cosecant, is going to be positive in quadrant 2. Okay, so it's going to be the negative of the square root of 1 plus 1/3 over 2, multiplied by 3 over 3. So same trick that we've been doing. That's going to be the square root of 3 plus 1 divided by 6. That's the same thing as the square root of 4 over 6, or the square root of 2/3, okay, or square root of 2 over square root of 3. And then if we were to rationalize that by multiplying by root 3 over root 3, this would turn into the square root of 6 over 3. Okay, that's probably the nicest answer we can get out of this. If we wanted to now find the tangent, okay, now remember, and by the way, this should be negative. I forgot to carry the negatives along with this. All right, so negative, negative, and this should be a negative root 6 over 3. So sorry about that. Everything else is fine. All right, last thing we do is we find the tangent of theta over 2. All right, and we could do that in one of two ways. All right, we could just use sine of theta over 2 divided by cos of theta over 2. That's probably the easiest way to do it. Which would mean we would just take, remember for this one, we got square root of 3 over 3. So that's root 3 over 3. And then for cosine, we just got negative root 6 over 3. We multiply by the reciprocal. So we have root 3 over 3 times negative 3 over root 6. Those cancel out. We would have negative square root of 3 over square root of 6. Because they have the same index on the radical, square root, we could just write it as one bigger radical. This simplifies into the opposite of 1/2, which now simplifies into the opposite of root 1 over 2, which is the opposite of 1 over root 2. And then if we rationalize it, that just gives us square root of 2 over 2 negative. Okay. All right. One last example, same thing. We have the sine of theta equals -4/5, and that theta is in quadrant 3. Okay, so just like we did before, first thing we're going to do is we're going to figure out, okay, well, where does theta over 2 lie? All right, now if theta is in quadrant 3, that means it's between 180 degrees and 270 degrees. Okay, so if we're in here, we're looking at angles that sort of lie in this quadrant. Okay. Well, that means that if we divide everything by 2, 90 less than theta, 135, okay? And so that means that theta over 2 lies in quadrant 2 again, right? So that's an angle that's somewhere like between here and here. All right, so if this is like 135 degrees, this is where our theta over 2 is going to lie. All right, so that's easy enough. And again, that means that in quadrant 2, only the sine function is positive. So this is going to be greater than 0, this is going to be less than 0, this is going to be less than 0. All right, so that's the first thing we always have to do with this. All right, now we're going to make a right triangle, right, ignoring the signs. All right, so this is theta, opposite is 4, hypotenuse is 5. We know that's going to be 3, but if we don't know for certain, we can just use our Pythagorean theorem. Okay, this is going to be 25 equals 16 plus b squared. We subtract 16 from both sides, 9 equals b squared, or 3 equals b. All right, so now we can go through and figure out what are going to be the rest of these values. Okay. One other thing to note, that the cosine of theta, since the cosine is in quadrant 3, or since the sine is in quadrant 3, that means that the cosine of theta is also in quadrant 3, which means that the cos of theta is also less than 0. Okay. All right. So that means that when we go through and try to compute this, okay, we just have to make sure that we're using the correct sign on this. Okay, so at this point, we're just going to use our formulas. So sine of theta over 2 is going to be, now remember, it's positive, and then we have 1 minus a negative cosine. And remember, cosine is adjacent over hypotenuse. Okay, so we're just using our formula for the half angle. Okay. Remember, our half angle formula is sine of theta over 2 is plus or minus square root of 1 minus cos theta divided by 2. All right. And so this is going to be 1 minus a negative 3/5 divided by 2. Or if I multiply by 5 over 5, okay, so our same tricks that we've been doing and distributing, this becomes now the square root of 5 plus 3 divided by 10, which is root 8/10. Right? And then when we simplify that, that just becomes the square root of 4/5. Square root of 4 over square root of 5. Square root of 4 is 2. And then we multiply by root 5 over root 5. So this becomes 2 roots of 5 divided by 5. Okay. For the cosine of, so this is for letter A. Now remember, the cosine of theta over 2, this is part B. Remember, that's equal to plus or minus the square root of 1 plus cos theta divided by 2. Okay. Now, our cos of theta is going to be negative 3/5. So this becomes 1 plus a negative 3/5 divided by 2. Okay, that's a minus sign here. Okay. And so we multiply by 5 over 5. Okay, just to clean this up a little bit. So that's going to be -3/5. We multiply by 5 over 5. And so that's going to be 5 minus 3 over 10. We know that 5 minus 3 is going to be 2. So we get -√2/10, which is the same as the opposite of √1/5, which is the opposite of √1 over √5, which is the opposite of 1 over √5. We multiply by √5 over √5. That just becomes the opposite of √5 over 5. All right. And then finally, we can go through and we can figure out the tangent just by dividing those two. So remember the tangent of theta over 2, we could just write that as sine of theta over 2 divided by cos of theta over 2. That's going to be 2√5 over 5 divided by -√5 over 5. Now we can multiply by the reciprocal. So 2√5 over 5 times -5 over √5. 5's cancel out, √5's cancel out, and we're left with just -2. Okay. All right. So those are our half angles at work. Okay. So in the last video in this series, we're just going to go ahead and prove a few identities or verify a few identities using our half angle formulas.